All right, hi guys. So I'm going to show you how you can use spreadsheets to analyze your data. So first thing, here is some data, mass and volume for 3 different sandstone rocks. You can see that I've put my units at the top of each column instead of throughout each cell, and that's important for when I show you what I'm about to do next. Okay, so you can do math with spreadsheets. So maybe I want to know what 2 plus 3 is. Or maybe I want to know what 2 minus 3 is. Or maybe I want to know what 2 times 3 is. And I got the asterisks here by holding shift and clicking 8. But you are finding density, so you don't need to do any of those operations. You need to do division. So now you could just do 4.8 divided by 2, which is what the mass and the volume are for this first rock. But if instead of writing out the actual numbers, you click on the cell holding that data, it turns it into a formula. B2 divided by C2. So 4.8 divided by C2, the contents of C2. And then if I hover over this blue corner and drag it, it will repeat the formula, but replace it with whatever cell is in that row. Okay? So look, it automatically did it for 6 divided by 2, and then automatically did it for 8 divided by 3. Super powerful. Great, all that's done. Now, what if I wanted to do an average? Really easy. Click equal sign. As you know, if you have to do math, you need to use the equal sign. Write the word average, open a parentheses, click and drag to highlight all of the data that you want to average, close the parentheses, and click enter. All right, so that's all of the math that you need to do to analyze your data. But now you need to do some science. You need to actually think. So first off, I Googled the density of sandstone, which is totally okay. Britannica.com, that is a reliable resource. That is a online encyclopedia. You could also look at the Wikipedia for sandstone. You could do a lot of different things. You could look it up in an actual book. Anyway, you see here that this source is reporting that a sandstone can be in this range of densities of 2.0 to 2.6 grams per centimeters cubed. So sandstone, you might remember from last year, is a stone made from sediment, from sand, from all different kinds of things. So it may not be the same throughout the world. And that's why you'll get this range of densities. So now when I look, 2.6, this number here really is not 2.6. It's 2.68. And if I was being careful with the amount of significant figures I'm allowed to express in my answer, because I obviously can't write all of these digits, technically I would only be able to use one significant digit because these volume measurements are not done with precision. They only have one sig fig. So this would round to 3 grams per milliliter, and that's not 2.6. So do we not have sandstone, or have we just introduced error into our experiment? You decide. That's part of what you explain in the discussion, right? But another little interesting hint is that, look, it appears that sandstone is made of quartz, and the density of quartz is 2.65 grams per centimeter cubed, or grams per milliliter. And so 2.68 isn't much bigger than that. Maybe we just have sandstone with a lot of quartz. All right, so that's just an idea of how you would do actual scientific analysis using background research, right? Do I know for sure if this is just highly quartzed sandstone? No, I have no idea. I'm doing science just like you are, okay? Now, another thing that you're gonna have to do in your discussion. So here's an example of the density of pumice that I saw somebody calculate earlier. These numbers are very different. You have to explain why. If you don't know anything about porosity and you haven't read about it, you should. There's a reading on my Milken attached to the lab assignment. And that might give you some explanation about why pumice might be so much less dense than sandstone, okay? But remember, in class, we learned about 2 things that affect the density of a substance. How far apart or close together the atoms are. So in a solid, they tend to be really close together, and in a gas, they tend to be really far apart. And then the density of the actual atoms themselves. Metals and larger nonmetals We don't really know what that means yet, but you can look up the density of atoms. And you can just find some information. Okay, does it tell me like what sandstone is actually made of, and are those atoms themselves denser than the atoms that make up pumice? Okay? If you're not sure where to find what the atoms are, then you have questions that you can ask. Let me see if I can find a quick example. I can't just looking at this actual image here, but you might see something like, oh, maybe it's made of Na, or maybe it's made of aluminum, or maybe it's made of silicon and oxygen, SiO2, that's what quartz is. Those are atoms. Those are in the periodic table of elements, and you can look up the density of those atoms and decide, is that explaining why these have different densities? All right, that's all I have for you on this little screencast, and good luck.